Now let's talk about advantages and disadvantages of always on. The first advantage I would say compared to database mirroring, you don't need to have a witness server. In the database mirroring, you need to use witness server to do the automatic failover. Here, it uses the Windows cluster quorum configuration to failover the services, the availability group from one SQL Server instance to another SQL Server instance. Okay, so I would say it doesn't need witness server. Okay, the second advantage is it uses log cache. In database mirroring, it doesn't use log cache. That may be the reason why it is little slower compared to always on. Always on caches the log records and the cache size can run in terabyte. Okay, so you will see the data movement much faster and always on. There won't be much lag in the always on compared to database mirroring. In the database mirroring, you will see whenever index maintenance or any heavy logging activity going on in the primary server, you will see considerable delay or lag in the secondary server or mirror server in the database mirroring. You won't see that often in always on because of the log cache feature, or the mechanism in the always on methods. Like that, there are several other advantages that I discussed in my previous videos. Now let's talk about disadvantages. Advantages, you can say backup preferences, load balancing. Okay, load balancing with the application intent use. Okay, like that, there are several other advantages. All the new features and advantages we looked into in our previous videos. Let's specifically talk about the disadvantage. The first disadvantage, or sometimes it could be a limitation, you cannot really say disadvantage. The first thing is tempdb. Okay, tempdb size. Tempdb size will become bigger and bigger. It may be because of the snapshot isolation. Okay, all the transactions that goes against the readable secondary, when you make the secondary database as readable, then every transaction that run against a secondary server will use the snapshot isolation level. Okay, like redo threads or your select queries, whatever the select statements, whatever the transaction SQL statements that you run against secondary server will use snapshot isolation. Doesn't matter whatever the isolation you set on the database, it will be snapshot isolation level that will be applied to the transactions. So what is the real disadvantage here? If you really study the snapshot isolation level, it uses row versioning to attain the snapshot isolation level. Okay, so to use the row versioning, it uses the snapshot version of the rows in the tempdb by utilizing the 16-byte characters. Okay, so even the redo threads, it uses a 16-byte for every LSN that it applies against a database. Okay, so your tempdb might grow a little larger, so you have to allocate more space for the tempdb. Okay, that is one disadvantage. And the second disadvantage, sometimes you might want to write the record in the primary and read the record in the secondary. Okay, because you might think that okay, the node 1, node 2, the primary and secondary are in synchronous data transfer. Okay, so instead of reading from primary, let's read from secondary. Okay, in the same transaction, for example, you open a transaction. In the transaction, first statement is insert a record into the primary database and read the same record from the secondary database immediately after the insert. Okay, logically, if you think that should be possible, because when you insert a record, the record is inserted in both primary and secondary because of the synchronous commit, but it doesn't work all the time. Okay, because the log is, it might be still in the cache, or it might be just hardened in the log. It may not really appear in the data file because there might be a few delay with the redo thread. Okay, so any immediate reads of the same data that inserted just before might not be there in the secondary database. Okay, so that is a slight limitation that you have to aware of. You can call it as a disadvantage. You can say immediate read after write or update on primary, immediate read on secondary may not give right results. Okay, now let's look into the another disadvantage: additional indexes on secondary. You cannot create additional indexes on secondary. For example, in our case, we wanted to redirect the reporting queries against the node 3 server. Okay, this is our primary server, this is our disaster recovery server, and this is our reporting database server. Okay, so in the reporting server we might want to create more indexes than node 1 than primary. Okay, so simply it is not possible. You cannot create index on secondary database. Okay, secondary database, you can read the secondary database, you can say read only intent, or you can say not readable. Okay, so in the read scenario, you might want to read the database, and the application might be little slower, and you might want to create the indexes, so it simply is not possible. Okay, but you can create the statistics, some temporary statistics, so that will reside in the tempdb. If you restart the node 3, those statistics will be gone. Okay, but you cannot create the indexes on secondary databases. That's a disadvantage. Whereas you can create the indexes on replication on the subscribers. Okay, that is not possible with AlwaysON. We cannot set the automatic failover for a clustered SQL instance. We have already seen that issue in our previous video when we set up the AlwaysON between a clustered SQL to standalone SQL. We couldn't do the automatic failover, so there is a limitation. Okay, due to the race condition, because SQL cluster has automatic failover feature and AlwaysON has automatic failover feature, so there will be a race condition happen. So that's why it has been removed. The automatic failover feature has been removed for cluster instance. Okay, that could be a limitation. Moreover, it's a disadvantage. And the other disadvantage, I can say, disk layouts. Okay, for example, you need to have the same disk layout on all the servers. Okay, the reason is, if you create a file, for example, I think we already discussed about this point. We have this database test1 on all 3 servers. Okay, the database, let us say the database test1 is residing on M drive, the data file is on M drive, and log file is on L drive. Okay, and this database we have set up the AlwaysON availability group. Okay, so now if I add one more file, NDF file or another LDF file in a different drive, let us say Z drive. In the Z drive, I'm going to place another NDF file. Okay, so when I issue the alter database add file command, the same command will be executed against the secondary replicas. Okay, so whatever the transaction that you execute on primary will be replicated on the secondary, will be re-executed, redone on the secondary databases. Okay, so when you say add the file on Z drive, so it's going to execute the same command, add the file on Z drive on node 2 and node 3 as well. Whereas if you don't have the file, the drive Z drive on node 2, then your replication will be suspended. Okay, it cannot execute the same command. So that's a disadvantage. So you need to have same disks layout. This is, I would say, a disadvantage. Sometimes you might be having 10 drives, M drive for data and N drive for additional indexes, and L drive for log file, X drive for backups. Like that. If you create a partition, you might be having some more drives. So in that case, it's a problem. In the reporting server, you might be having just one drive or a couple of drives with a lot of space. So you might want to put all the files on the same drive. So in that case, your always on might be put in disconnected status. So what you have to do in that case, you have to again break the always on, remove the database from the availability group. If the disk structure is different and you add additional file, or you change the file from one location to another location which is not there in secondary, then in that case it is going to break the always on. Okay, the data synchronization will break, it will be in disconnected status, your secondary replica will be disconnected. So in that case, it is well known that it will be in disconnected status. So what you have to do, just remove the database from the availability group, do whatever changes on your primary, and take the backup and restore it on secondary. And while restoring, you specify the location where the file is going to be. Okay, so every time when you add a file or change a file location, you have to take full backup and restore it on secondary backup. You have to do that circus. Okay, there is a workaround, but it's a little bit hectic. Okay, I would say these are the disadvantages. There could be some more, but I would say these are little bit I would say these are significant disadvantages of always on. All right, let me show you a couple of other things. Okay, logins. When you fail over the databases from node 1 to node 2, you have to make sure you have to have the appropriate logins, same logins on node 1 to the node 2. Okay, so what you can do, you can copy the logins. There is a script, Microsoft provided the help rev login. There is one system, there is a procedure, stored procedure. You can use the stored procedure and generate the login scripts and execute the script, login script on secondary server. So when you fail over the services, the database availability group, then you can use that login. Okay, so you will not have that orphan login issue. Okay, sometimes you may have to use the contained database. Contained database means login information will be in the master database. Okay, the user database will be in the user database. So contained database means the user database contains the entire login information. That means login and as well as the user, both the information will be stored in the user database. Okay, so sometimes you may have to use the contained database to avoid the login issues. Okay, so for that you have to change the database. It says recovery pending. Let us see what the problem is. Okay, now let us see what the problem is. Okay, so here it says node is down. Not sure why the node is down. Um, Cluster is down. Let's bring the cluster services up. Okay, so now we have the cluster services up. Basically, you should not be poking around with the cluster. I just wanted to show you how availability group uses the cluster, but basically you should not be touching the cluster. Availability group manages the cluster. Okay, so whatever you wanted to do, you have to do it through management studio. Okay, so it manages. So even the quorum goes down, cluster cannot come up, still you can manually bring it back from the management studio. Okay, so basically you should not be coming to the cluster and uh, doing anything here. So typically you can even come here and do a failover. Okay, so like how you do a failover in the availability group, you can come here and do a failover. Okay, but don't do that, because when you do it from management studio, it has to execute some SQL statements before doing the failover. Okay, it has to make sure the transactions are up to date, apply any transaction, roll back or roll forward the transactions, and bring and alter the database to make it as a primary or secondary. It has to execute a lot of SQL statements before or after the failover. Okay, so if you just go and blindly do the failover here, then you are putting your databases at risk. Okay, so don't ever do that. But you can see how availability group uses behind the scene to do a failover. So failover is just one part of availability group failover. Okay, when you say failover in availability group, it does more than what cluster failover. Okay, but sometimes really annoying things will happen. In this case, the node went down, the cluster service went down. I don't know why. That's why when I do a failover here, it's not working. Now it's a secondary because the cluster node appeared and back online in the availability group. And you can see the quorum information here. So who got vote? So basically it has got odd number of votes to stay healthy. Okay, so you can see here the quorum information. Okay, and in the availability group, you can view the failure level. That means when it receives a particular value, where value ranges, the failure value ranges from 1 to 5. Okay, so when it receives a particular value, not here, I think should be here. You can see failure condition level. Okay, the failure condition level ranges from 1 to 5. You can change the failure condition level either to 4 or 3. If you think 3 is little low, you can increase it to 4. But again, do not change the value here. You can change the failure condition level from GUI. Let us see. Okay, primary is secondary, right? So let's do a failover. Let's do a failover to node 1. Okay, so now I'm on node 1. You can say alter the availability group. For example, here AG1 is availability group name, and says condition level equal to 2. Okay, so we have to use the master database to set that command. Okay, now you can see the value is updated here. Okay, so you can either change it here or TSQL, doesn't matter, but better to do it in TSQL so that it can appropriately change the value here. So you need to really go through the various failure condition level from 1 to 5 to understand for your environment which level suits best. Okay, but by default it comes with value 3. Default value is 3. Regarding the licensing, uh, if you have just one passive replica, then you don't need to pay additional licensing. But if you are using multiple secondary replicas, then you have to pay the license for the additional secondary replicas. One passive secondary replica license is not required, but you have to pay the license for additional secondary replicas. Okay, that is something you may have to really watch for it before you set up additional replicas. You have to pay the licenses. Okay, and again, the licenses are not by socket based physical slot. You have to pay per core basis. Okay, so you have to check with the marketing salespeople to see how much it would cost to implement or install SQL Server. Otherwise, you have to limit the SQL Server. If you are purchasing particular number of cores, you have to really limit the usage of number of CPUs in your server. If you go here properties, then you can see the list of CPUs. You can limit the usage. Okay, so I was talking about the contained database and I stopped in between. Let me show you what the contained database means. If you go to the properties, you will see the options containment. Okay, this is something new added in 2012. Okay, you can see here this is not a fully containment. Okay, so you can see right now by default is none. You can set it as a partial, but in the future Microsoft will implement full containment. So what is containment means? Containment means the database, it contains everything. Okay, you don't need to depend on external resources or external factors. For example, now the log, you have the users in the database. Okay, you have logins. So when you connect to SQL Server, you have to use the login, but login is mapped to a user in the database. Okay, so user is not complete. It has to depend on login. Okay, now if you say containment partial, okay, partial containment, okay, that is the only option right now you have available. There is no full containment at this time. In the future maybe. When you say partial containment, that means you are storing the entire login user, all the crap, everything in the user database. So you can so when you move the database from one server to another server, you don't need to worry about moving the logins, because the login information along with the user permissions, everything is in user database. You take backup and restore it on some development environment. You have all the logins and passwords, everything. Okay, so when you connect to the SQL Server and when you use the containment user, then you have to connect to that particular database. When you say master, it will not connect because it doesn't have information. You have to specifically connect to that database because that database has the login details containment. Okay, so this is something new that has been introduced in 2012. Maybe you can use this feature to move the logins from primary server to secondary server, or you have to move the logins manually. If you don't use the containment, then you have to move the logins manually, run the login script and execute the login script on the secondary servers. Otherwise, when there is a failover from one node to another node, your application cannot connect to the other node because there is no login there, unless you create something like a containment type database. Okay, It's a little bit out of scope, but let me explain. You say containment, okay? Contained database authentication means not okay. There is something you need to reconfigure. You need to issue SP configure to use the contained database authentication feature. Okay. All right. Let's do that. Contained database authentication. Okay. So now you have the. Now let's execute the same on node 2 as well. Now let's execute the same on node 3 as well. Okay, because when we make a database containment, it will be replicated to the other database. So here I say partial containment. Now I have the database that has the containment. Let us see, the same has been replicated. Okay, it has been replicated to the secondary servers. Option partial. Okay, now the database is contained. Now let's create a user, containment user. Before that, let me show you, there is even you can go to the facets. Even you can go to facets and change the containment feature here. Okay, so let us see if there is, okay, containment enabled true. Okay, instead of executing sp configure, you can also just come here and make it as false or true, whatever it is. Okay, now let's create a login here. Now let's create the contained user. So in order to create, you can create a new user here. So here you have the option SQL user with password, okay, or SQL user with login. By default, when you create a new user, it will be SQL with password for the contained database. Test2 is not contained. Let's try to create new user there. If you try to create SQL user with login, because there is no contained database enabled here. Okay, so you can come here and SQL user with password. Okay, contained user. You can give read only. Okay, so when you say okay, so contained user. Okay, so now let's connect to the node 1. Before connecting to the node 1, let us see. So here you don't see that contained user. Okay, but let's try to connect to node 1. you have to specify the name. Okay, so simply you cannot say contained user and password and leave the database as blank. Okay, it will not connect because you are not using the typical traditional login to connect to the master database. Okay, so you have to specifically say to which database you are going to connect, because the login and user information, everything is in the database. So you have to specify the database in order to appropriately connect. So you specify the node, the user and password, the SQL authentication, okay, will be stored in the database. So you can connect like that. So this is contained database. So this is how you log into the contained database. Now what we do a failover. Now we do a failover to node 2. All right, we failed over to node 2. Now let's connect to node 2 using okay, we got connected to node 2. Okay, so let's try to connect through AG listener. Instead of node 2, let us connect to AG listener. Here now I say contained user. Okay, now I am able to connect. Okay, so this is how generally application should connect to the availability group databases. When you connect to the listener will appropriately route the request to the primary node, whichever primary replica is uh, available. Then in that replica, whatever the user information you have sent, you have given the user ID password, which is a contained user ID in the test1 database. So it's successfully connected. Okay, you can directly connect to the node 2, or you can connect via the listener. Okay, so you can use contained database to get rid of the login, moving the logins appropriately. Then you might think about jobs, other things, other objects in the server, like maintenance tasks, SSIS packages, jobs, linked servers, etc., etc. So those things you have to create on every server. Okay, uh, if you are going to fail over to node 2, you have to make sure you have all the jobs, everything on the node 2. Sometimes so if you have you have to copy all the jobs from node 1 to node 2 and keep it ready. So in the job you might want to write a code. If this replica is primary, then execute this job, then execute this script, something like that. Otherwise the job on the all the replicas will start executing if you don't put a condition like that. Okay, so it might be a problem. So you have to appropriately code the logic. If it is primary replica, then run the step, something like that. Okay, otherwise you can create some logic in the in the TSQL script, or you can write WMA script. You can write some kind of script to enable a disable job. For example, my primary replica is node 1. Okay, and all the jobs in this replica, SQL Server agent jobs I am talking about, all the jobs in this replica will be executing. You have the same jobs in the node 2. This is the secondary replica, let's say. Okay, you have to keep the jobs in the secondary replica in disabled status. So you should write a script to disable the jobs whenever there is a failover occurs. Whenever there is a failover occurs, and if this replica becomes secondary role, if this replica takes a secondary role, then you have to disable the jobs in the server. Okay, otherwise these jobs will start running. Okay, so you have to do something. You have to run the jobs in one place. Wherever the primary, you have to run the jobs in that place.